market line ka concept. We'll finish off this. Easy only. Come to page number 20, sir. Yeah. Sir, this is our next concept, sir. This is a very small concept, but in this beta one new formula also will be coming. Already you know 3 formulas for beta. One is sigma security into correlation divided by sigma market. The other one is covariance between security comma market divided by sigma market square. The third one is a very rare case where correlation is +1 or -1. Change in security return divided by change in market return. That is the third version. Then there is a fourth formula called as a regression equation that we will discuss in the course of this. Okay. Now, forget about beta for a moment. Characteristic market line equation. Guys, in this model, we are establishing a link between market and security. You are establishing link between security and the market. Till now, all the graphs we have seen, we are establishing relation between risk and return. This is the only graph where, or line equation where, the relation is not between risk and return, it's between market and the security. I'll give you a simple example, later on we'll start. Example number 1, market return, security return. Let's say market return is 10%, 11%, 12%, 13%, 14%. Last 5 years. Security return in the last 5 years was 20%, 22%, 24%, 26%, 28%. What can you observe? For every 1% change in the market, security is changing by 2%. Market is increasing, security is also increasing. Market is increasing by 1%, security is always increasing by 2%. Every time same pattern is getting followed, correct? Now, if you plot these points on a graph paper by putting RM here and security return here. It is important, sir, remember this. Market return on x-axis, security return on y-axis. Why it is important, later on you will understand. All other graphs are optional. At the concept purpose, if the question directly it will come like this only. Understand. If you tell me, sir, when market is giving low return, security is also giving low. Market giving high, security is also giving high. Tell me, sir, is it positive relation or negative relation? Positive. So the line also should have a positive slope. It will look like this. Positive slope means if you give me less return, if market gives less return, security also give less return. E point will be here. Market gives high return, security also will give high return. E point will be here like that. It is positive sloping graph. Okay. Now, whatever points we have, all these points will perfectly form a straight line. Now, if you ask me, sir, what is the line equation for this? What is the straight line equation? Straight line is equal to y is equal to mx plus c. Tell me, ma, y-axis में the whom did we plot? Y-axis, security return. So this is security return. C, we'll talk about C later on. What is M? M is called as slope, correct? Is slope. Now carefully observe what I'm trying to say. Do you agree that in this case, market and security are always going together? Market and security are always going together. If market and security are always going together, in case, sir, correlation is equal to +1. When correlation is equal to +1, straight line will come like this. We know that correlation +1 is straight line will come. For a straight line, what is the slope ka formula? y2 minus y1 by x2 minus x1. Who is y2 minus y1? Any 2 points on y-axis by corresponding points on x-axis. That means change in security return divided by change in market return. What is that? Beta formula. Slope is nothing but a link between these two. The link between these two is what? Beta. So M place I am rating beta security. X place who is there? Market return. Plus. Guess who is C? In the previous models, when we learned capital market lane equation, when we learned security market lane equation, C was RF. Why C was RF is, this axis we plotted what? Risk. When risk is 0, e line whatever it cuts here, that will be risk free return. Andukani RF. But e graph lo idi risk? No, adi market return. So what is this line indicating now? E cutting point is what? If market return is 0, security will give you how much return? A point. This coincidentally, unfortunately, also called as alpha. This is not the alpha what we learned. Adi Jensen's alpha. Jensen's alpha is expected return minus required return. This is not that. This is return of security when market return is 0. This is definitely not Jensen's alpha. So till here you understood. Now, in this one small problem is there. What is this is? Generally, security ka correlation with market will not be +1. Generally, it won't be like that. Why? Tell me, sir. Security will dance only because of systematic factors, or unsystematic also? Unsystematic also. That means what? Some portion of the risk of the security comes because of their own specific factors. If you say R is equal to +1, you know what you are saying? I will literally move whenever market moves. Market doesn't move, I also will not move. Our cases are very rare, no sir, because every company will be doing some of the other stupid business. Our business, some problem is there, some goodie is there, that will impact only that security but not the entire market. So R will not be +1. The understanding I started like this, but in normal cases R will not be +1 between security and market because security has its own reasons for fluctuation also, apart from macroeconomic factors, which is systematic risk. Now, when you tell me that R is not equal to +1, then you know what will happen? Straight line will not come. Points will be scattered like this. When points are scattered, straight line will not come. How will you write line equation? Let's see. When R of security comma market is not equal to +1 or -1, then points on the graph are scattered. So let's say ఇది RM x-axis, ఇది return of security y-axis. My points are like this. Like this. The points are scattered like this, sir. When points are scattered, when points are scattered like this, how will I frame a line equation for this? How can I establish a relationship between these two? X-axis ki, y-axis ki, if I have to establish a relation, it should be a straight line. If it is not a straight line, equation how will I establish? I can't establish. Here only, statistics, sir, when you're in your foundation or somewhere, you might have studied a concept called as a regression analysis. Correlation and regression. Why they both are studied together is, when correlation is +1, natural straight line will come. You need not do any regression there. But if correlation is not +1 or -1, straight line will not come. Points are scattered like this. When points are scattered like this, how will I draw a straight line? It will come like this. A straight line, huh? That's not straight line. So what we will do is, we'll create a dummy straight line now. A dummy straight line is called as a line of best fit. E line is called as a line of best fit. It will not touch any of the points. So then what is the purpose of this point? What is the purpose of this line? E line will work like this. If you tell me, sir, in any particular year, you tell me, sir, RM is giving 20% return. What is security return? According to this line equation, the answer will be 22%. According to the formula. But actual return won't be 22. It will be 24. There is a gap. Why there is a gap? Because this is not correct straight line, because dummy straight line. Therefore, wrong answers will come. So there is an error or not now? There is a small error. Like that, here also one error, here also one error, here also one error, here one error, here one error. All the errors ka sum total will be 0. That is a line ka specialty. You will draw a line in such a way that a line will give you wrong answers. But all the wrong answers ka total will be 0. Okay, now, again tell me, sir. A dummy line ka equation form I am writing. Y is equal to mx plus c. Who is y here? Again, Rm. M is beta. X is what? Security. C is what? Alpha. Whatever we did here, same thing I did. Only difference is, this original genuine straight line. This perfectly it will work. You tell me, security return of, sorry, I wrote wrongly. I understood. Interpretation will catch, no sir. Yeah. If you tell me market return of any year, I will be able to write security return. I will get the security return if you tell me market return. E case law, if you tell like that, it will match. E case law will not match. Why will it not match? Our points will fall on the line, but actual returns are standing outside the line. Therefore, there is error. There is error. There is an error here and here and here. Now, what is that error indicating? Correctly understand the concept, last point over. A error indicates that securities will fluctuate for reasons other than market also. According to this line, for this level of market return, is security, for this level of market return, the security should give this much return. But security actually is giving higher return. A extra return, whatever is coming, that is coming not because of systematic factors. Then that is because of unsystematic factors. Similarly, if fall is because of unsystematic reason, if fall is because of unsystematic reason, if rise is because of unsystematic reason, that is a reason. Unsystematic risk is also called as a random error. Thing which I can't explain is called as error. A error is because of reasons other than market. Who is reason other than market? Unsystematic risk. That's why unsystematic risk is also called as random error. Unsystematic risk, how are we rating? Sigma error security square. Why are we calling it as error? Is the background for that. I tried to fit a line, sir. You are not falling on the line. You are going out of the line. Why? You just only you will impact. I have my own reasons. They have their own. Every company has got their own reason. That is called as what? Company specific risk. That only we are calling it as what? Unsystematic risk. Unsystematic risk is plotted in the graph in the form of a error gap. That's why unsystematic risk is called as random error. Am I clear till here? Now, so tell me now, if I apply this formula, will I get red dot or will I stand on the line now? If I apply this formula, I will fall on the line, but actual reality is far from it. There is a gap now. That's why for denotion, we write like this. Plus error. Just for the sake of it, we'll write like that only. Because if you do only this, it will not match. There will be gap. A gap is called as what? Error. A error is nothing but what? Unsystematic risk. Clear? Now, questions they will ask you, fit a characteristic market line. They'll give you some stupid data. Past 10 years returns, 5 years returns they'll give you. They'll ask you, security ki market ki link you establish and create a line equation for us. Now, how will you create a line equation? Simple steps, sir. Watch this. Very, very easy steps. First step everybody knows. Compute beta of security. You tell me all the formulas you know. Yes, sir. Beta security is equal to sigma security into correlation between security and market divided by sigma market. Sir, if you have to apply this formula, you need to draw a 9-column table. Do you understand? Why? Correlation you have to get means a 9-column table you want. Sigmas you want, 9-column table you have to work out. No option. Either this or covariance of security and market. Here also 9 column table you have to do. Divided by sigma market square. Then there is another cute formula now. When R is equal to plus or minus 1, then you can do change in security return divided by change in market return. Sir, if it is this case, error will not come. In third case, error will not come. Why error will not come? Your points are perfectly falling on a straight line. If formula, if I work out security return, that will exactly match with actual return also. Error will not come. Error will come when R is other than plus or minus 1. That's why in the questions when they ask you, they won't give you this third case. Characteristic market line questions, E case will not come. But now I'm writing BTech formulas I wrote. Now your fourth formula is coming. Wait, I'll check whether I've given here or not. I've given here. Wait a moment, some mistake is there in this. Summation of xy into summation of x bar y bar, summation of x square, correct only. Everything is right. No sir, there is an alternative formula also for that. Summation of x into y minus n into x bar y bar divided by summation of, I wrote wrongly here, wait. Correct only, no. Summation of x square minus x bar whole square. Now, if formula looks very ugly, I agree. But if formula one advantage is there. What is the advantage is? Normally, if you have to work out beta originally, you need how many columns? 9 column table you have to draw. After table also again formula you have to apply and get it. If formula somehow if you by heart it, I can derive this also. For this Carl Pearson coefficient regression equations are there. Waste of time, sir. Leave it. If formula if you by heart it somehow, 4 column table to beta will come. In this only mistake people do is understanding who is x, who is y. Beta is link between who and who? Security and market. So who is x, who is y? You can't assume whatever you want. Good. That's the reason in graph I ask you to remember. X axis who is sitting? Market. So x is market here. So when we say x, this is market returns. Y is security return. X bar is what now? Expected return from market. Y bar is expected return from security. N is number of years. Past data, how many years you are taking? Every questions are invariably. First column they will give you return of security. I'll show you all the questions. Almost all questions, first column will be security return. Those who want to apply this formula will assume invariably, inadvertently that as x. Gone some. X is market return here. Sir, how will you remember? Don't remember. E graph, e concept you remember. Indirectly, one small concept I will tell you, sir, but that is not always right, but most of the times it is right. What is that is? When you are framing a graph, dependent variable will be there on y-axis. Independent variable will be there on x-axis. Beta, sir, you are framing relation between who and who? Security and market. Tell me interpretation of beta 1.5. For every 1% change in market, security dances by how much? Correct? So tell me who is dependent, who is independent? Security is dependent, market is independent. So our independent fellow will come on x-axis. Y-axis dependent fellow will come. This is general. So obvious same goes with risk also. High risk, high return. Low risk, low return. That's why risk is on x-axis, return is on y-axis. It's like that. The general statistics works. Dependent fellow will sit on y, independent fellow will sit on x. That's how we frame. Okay. Now, sir, the formula how to handle? Sir, you just have to remember numerator. Denominator what you have to do is, numerator wherever y is there, so replace it with x. I denominator. Here if I put x, what will be? Summation of x square, this one. Y bar, make it x bar whole square. Just a numerator, if you remember, replace y with x, that will become denominator. Some shortcut, no sir, because original derivation is there. Even if I derive it also, still you have to remember this. You better remember this. Why to derive and show? This is step number 1, sir. The beta, first step over. Step number 2. Compute alpha of security. Compute alpha of security. Alpha is return of security when market return is 0. This is not Jensen's alpha. This is important, sir. See, I cannot change the notation there. The alpha places some gamma or something else. If I write, example will get confused. In this entire chapter, 2 alphas are there. One is CML, characteristic market line, one alpha, other one is Jensen alpha. Okay, E alpha, how to compute? It's simple, sir. Watch this. Our equation is this, no? Security return is equal to beta security into RM plus alpha plus error. This is our characteristic market line equation. In this, use this equation for expected returns. What is the meaning of using this equation for expected returns? Means everywhere put bar. So R security will place, who will be there now? R bar. Beta is constant number, that is beta only. This is RM bar. Alpha will come. Sir, what about error? Tell me, sir, how will you calculate bar expected and how will you get when past data is given? When past data is given, how will you work out expected return? Simple average, that means you will add up everything divided by n. Last 5 years ka security return you are having. What will you do? Simple average. This number will come. Last 5 years ka market returns you are having. You will simple average it. This will come. Beta already came. Alpha we do not know. Error. Last 5 years ka error you compute. A error ka average you have to do. What did we discuss? A line is drawn in such a way that the error ka totals, if you see, it will become 0. The moment you try to take average, it will burn to 0. If you want, I'll prove it while doing the sum. Pakka it will become 0. So E part will become 0, sir. Since sum of errors is equal to 0. That's all. That means we know this, we know this, we know this. This one, find now. Alpha వచ్చేస్తుంది, sir. All you have to remember is y is equal to mx plus c. That's all. Sir, I can already change it here and there and give you one new formula for alpha also. But I don't want to do that. Too many formulas are bad, sir. Anyway you will remember. Sir, how will I remember, sir? I did not remember. It is simple, sir. This graph రాసేయండి first. Y is equal to mx plus c. Who is y? V to y. V to x. Relation between these two is beta, the m. C is alpha. There is nothing to, sir, they are looking new, but they are not bad, as bad as they look. Basic y is equal to mx plus c, nothing else. That's all now. First step lo beta over, second step lo alpha over. Step number 3, you just have to code. Write over some, just have to present it in equation form. Write characteristic market line equation by substituting. What did we compute in step number 1? Beta. Step number 2, alpha. That's all. Remaining equation, leave it like that. That's all. The 8 marks stuff, sir. Beta calculation, alpha calculation is joke, one line calculation. The plain equation, if you write 8 marks, they are giving this question for. So, how will it look like? Security return is equal to beta into market return plus alpha plus error. We do not know what is that error. Unless you put something, we do not know how much error will come. Simply write error. Now, R security we don't substitute. Beta placed at 2 I'm writing randomly. Example. RM. Alpha let's say is 10 plus error. That's all over sum. You just have to frame this equation and leave it. If your R is equal to plus 1 literally, then error will be 0. No error will come. Error is coming because that is not a straight line. The line of best fit, average line. Because of that error comes. A error conceptually indicates that security return dances for reasons other than market. That is what unsystematic risk. That's how error term comes. Clear? So once if you check this here, where is this? Step number 1 is beta, sir. Step number 2 is alpha. Step number 3 is just write the equation. That's it, over. Your ultimate answer will be a plus error. Even if you write, you don't write, doesn't matter. So because error number anyway we do not know. That's it, over. Okay, sir. Take up the question. Come to question number. You can do 84 also or 86 also. Anything you can solve. Wait a moment. Which one will solve? 86 you solve. Easy, cute. The returns on stock A and the market portfolio for a period of 6 years are as follows. So return from A is given, return from market is also given. 1, 2, 3, 4, 5, 6 years data. You are required to determine characteristic line for stock A. So characteristic market line you have to work out. And systematic and unsystematic risk of stock A. Once you work out characteristic market line, whatever risk of the security is there, that you have to again break it into systematic and unsystematic using sharp single index model wala formula. That is easy only, sir. Systematic, unsystematic, that's easy only. That's not a problem. So let's first work out characteristic line equation. So question number 86 it is. Prepare a 9-column table, sir. Security return, expected return, deviation, deviation square, RM, RM bar, deviation of market square, deviation of security into deviation of market. Now fill up all the data, sir, one by one. 12, 15, 11, 2, 12, 15, 11, 2, 10 minus 12, 10 minus 12, 8 plus 12, 11 minus 4, well, sir, now that this is past data, please total this up. First column ka total is 38. Now that I have total, I'll work out expected return now. How many years returns is this? 6, 6. So 38 by 6, 6.33%. So that would be 6.33, 6.33, 6.33, 6.33, 6.33, and 6.33. Deviation 12 minus 6.33. See, now that this is past data, in the next fourth column, I want total alone because I will not multiply with probability of each product or each square. So directly do on your calculator and fill up this. There's no point of wasting time by writing each and every number there. 5.67 into equal to 8.67 into equal to 4.67 into equal to 4.33 into equal to 3.67 into equal to 18.33 into equal to GT 497.33. Sigma A is equal to 497.33 divided by 6 under square root 9.104. Right. Next one, market return. Market return का total 20, 31, 31 minus 4 plus 7.5, 34.5. So RM bar 5.75. Okay. E 5.75 you fill up. Eight minus 5.75 is 2.25. 12 is equal to 6.25. 11 is equal to 5.25. Minus 4 is equal to minus 9.75. 9.5 is equal to 3.75. Minus 2 is equal to 7.75. 2.25 into equal to 6.25 into equal to 5.25 into equal to 9.75 into equal to 3.75 into equal to 7.75 into equal to GT 240.875. Now carefully multiply deviation to deviation. 5.67 into 2.25, it's 12.7575. 8.67 into 6.25, 54.1875. 4.67 into 5.25, 4.33 into 9.75. Minus of minus will become plus there, so that's 42.2175. 3.67 into 3.75 will be 13.7625. 18.33 into 7.75. This is minus no last one. 142.0575. Well, total it up. $289.5. Check once. Same answer? Well, this is not covariance. You have to average it. Summation of deviations divided by n. 6 observations divided by n. If you do, you will get covariance. Sir, I just wantedly don't fill up this column out of my laziness and also because it is not required. We need product of these two. E total is enough because it's past data. If it is future data, I did not have a choice. I have to write all of them. Now also you can write if you want. Okay, rest of the data. Sigma market 240.875 divided by 6 under square root 6.34. or 336 is fine. Okay, then covariance between security and market is equal to last column ka total 289.5, no square root business 48.25. You must understand that it will be in square terms. From the beginning we are developing that concept. Suddenly previously you have seen some questions on how they manipulated the question. Careful. 48.25 whole square. That's all. Now you see, why did we work out all this is, if you have to determine characteristic market line, the first calculation you have to do is what? Beta. So next step we will work out beta now. Okay, right. Do one thing if possible, somewhere go and insert step number 1. Compute beta. Okay, now beta of security A is equal to sigma security into correlation between, covariance formula will use, covariance between security and market divided by sigma market square. If you work out correlation, other formula also you can work out, but that's not required. 48.25 percentage square. Sigma market is how much? 6.336 percentage whole square. 6.336 divided by 6.336. 1.2018. 2019. Wrong answer, huh? Well, sir, that is that. This is your beta. Now, they also did in the same type. They also got the same answer. That's okay. Now, listen here. We recently developed a new formula. Summation of xy minus n of x bar into y bar divided by summation of x square minus n of x square. We developed x bar whole square. We developed that. Instead of using that, why did we do a 9-column table here? The reason is, sir, if you do that 4-column table, that new formula, you will get beta. No problem. Beta will be same answer. I'll prove it also now. But the problem is, second question, what is he asking? He is asking you to break the risk of the security into systematic and unsystematic. For that you have to work out what? Risk. Again a 4-column table you have to work out. And moreover, systematic risk of security formula is what? Beta square into sigma market square. So I need sigma security also, sigma market also. So 9-column table is best for this sum. Question need not tell you, you must think. Second question, you have to work out systematic risk of the security, unsystematic risk of the security. Systematic risk of the security formula is what? Beta into sigma market square. So I want sigma market. Unsystematic risk of security, how are you working out? Total risk minus systematic risk. So I want total risk of the security also. So 9-column table is best for second bit, considering the second bit. If only characteristic market line, only beta you want, then instead of 9-column table, a 4-column table will do. Okay, but E sum ki correct, sir. This will save time for you at once. Now, for proving that that model also will give you correct answer, I am doing it. Examiner do not do, because next some 10 years data is there. There I will make you do 4-column table now. I have to prove no both the methods will give you same answer. For that I am doing here. Alternatively, the examiner do not do, sir. E sum ki whatever we did above, that is only correct. Alternatively, beta can be computed using regression formula. Sir, there are questions where shamelessly they will ask compute beta using regression analysis. You know this version, but they will not ask, they don't want this, they want only this. So you have to compulsorily learn this, and in fact it's easy actually. So beta security is equal to summation of xy minus n into x bar into y bar divided by summation of x square minus n into x bar whole square. This formula another alternative version is also there. I don't want to give that, sir. That will be very huge. ఈ x bar is nothing but summation of x by n. ఆ n will die. ఆ LCM తో n will come down. It's waste formula. Leave it. Keep with this. So here just write one small point that who is x, who is y. X is equal to market. Y is equal to security. If you understand that, rest of it is over. Market return you write. It's better. This is security return. Now I need only 4 columns, ma'am. One x, which is nothing but brackets, so clearly write market. Second column y, which is security return. X bar, y bar will compute anyway. Now I want xy, product xy, and I want one x square. That's all. 4 column though I will get the same beta like what we have right now. Tell me numbers now. Column x, 8, 12. Careful sir, market data you have to copy. 8, 12, 11, minus 4, 9.5, minus 2. The total already we did earlier, same total, 34.50. X bar 34.5 divided by 6, 5 point something you told me earlier, 75%. Y sir, y means security returns. 12, 15, 11, 12, 12, 15, 11, 2, 10, minus 12. The total was 30, exact 38. 6.33. X into y. 12, 8, so much? 96. 12, 15, 180. 11, 11, 121. 4 to 8, negative. This is 95. This is 24. 96 plus 180 plus 121 minus 8 plus 95 plus 24. 508. It is summation of xy. X square 8 8 is 64, 12 square 144, this is 121, 16, this is how much sir? 90.25, 9.5 into square, correct, 90.25, 2 square on calculator is 4. So this plus this plus this plus this plus this 439.25 is summation of x square. So now I have x square summation, xy summation, x bar, y bar with me. One small formula, so beta is ready. 9 column table you can avoid if you remember this formula correctly. 4 columns, so answer will come off. Okay guys, handle this beta formula, substitute it. Beta security is equal to summation of xy to 508 minus n, 6 observations, x bar into y bar to 5.75 into 6.33. Denominator lo sir, wherever y is there you have to place x. Summation of xy will now become summation of x square, 439.25. N is n only, x bar whole square. $289.615 divided by 5.75 into equal to into 6, 439.25, 240.875 divided by equal to into 289.615, 1.202. How much did we get above? 1.2019. That's almost same. It's just a proof, sir. You need not, and in fact, E particular sum kit do not do this. Because E particular question, second bit they are asking systematic and unsystematic risk. E model if you work out beta, You can't break that systematic and systematic. Anyway, we are still in step number 1. Don't forget that. Step 2 is what? Alpha. Characteristic market line equation is equal to is y is equal to mx plus c. Y is security return, m is beta, x is rm, c is alpha. Applying this equation for expected returns, then how will it look? Expected of security is equal to beta of security into rm bar plus alpha. Sir, if you want, you can write error also, but a error ka average when you take, that will become 0. If you want, I'll prove it. That's not a problem at all. Okay, now fill up. Expected of security, we know that 6.33, 6.33. Beta 1.202. RM bar 5.75. That's all. Alpha will come out now. 1.202 into 5.75 plus 6.33 minus 0.58. 5815 is there, leave it, or if else you can write one. Sir, how can risk-free rate be negative, sir? Who told alpha is risk-free rate? Alpha is not risk-free rate. Alpha is what? It is the return of the security when market return is 0. X-axis, the risk is not there. RM is there. When RM is 0, security will give this much return. That's the meaning of that. Over. Step number 3, skeleton equation you write and leave it. Characteristic market line equation. Already we know the equation. Security return is equal to beta security into market return plus alpha plus error. Security return, don't fill up, leave it. Beta 1.202. RM we should not fill up, plus alpha fill up, plus minus 0.58. That's all, sir. Error, if you want, you can write, or else you can ignore it. That's up to you. Or else leave it. What is there? Error, why we write is equation is not correct equation, hint. That's all, conceptually. It's not that error will find out and write. That's all, sir. This is done for us. Now, what is the question asking you to do now? They are asking you to break the total risk of the security into systematic and unsystematic. So that is something which we are pro at. Sir, for this much only, you have to work out beta, step 1, step 2, alpha, step 3, equation. That's all. Ide 8 marks straight away. Nothing else you have to do. Whether you understand or not, you by heart it. But as such, it's not difficult. What next you have to work out? Second bit, systematic and unsystematic risk. You will tell me now how to work out systematic risk of security. Beta security square into sigma market square. Very well. Beta is 1.202 whole square. Sigma market somewhere we worked out. Where are you? 6.336. 1.202 to 6.336 equal to 58. You got same answer? Different answer? Same answer, no? 58.00. Leave chiller, kind heart. Next, unsystematic risk. What's the formula? Sigma security square and total risk. From total risk, you have to eliminate systematic risk. Total risk we worked out somewhere. Where are you, Babu? Sigma A 9.104. Another standard deviation. This is square terms. 9.104 whole square minus 58 percentage square. 9.104 into equal to minus 58. 24.8828 percentage square. Sir, if you want answer in percentage terms, root it. I don't have a problem. But when you want to work out total risk, if you add percentage plus percentage, you won't match. This alone percentage, if you want, do it. This alone, if you want to do it in percentage, finally root it. But our final percentages, when you add, it won't match with your total risk ka root. Be careful. That's all. Sum is over. What's the answer he got? You got different answer. Huh? Same answer. Huh? 24.9 he got. How much did you get? Same answer. That is okay. Small error only. Rounding off error. 57.99 systematic. How much did we get? 58. That's almost near. Don't mind. So till here you understood, all of you. There is nothing very extraordinary we are doing, sir. We are simply framing a line equation between market return and security return. They won't form a straight line. That will cause an error. Straight line is not coming. Therefore, a line is also a dummy line. Because of that, error comes. A error indicates that security returns will fluctuate because of reasons other than market. That's why we are calling that as what? Unsystematic risk or random error. Here. Now, I'll do one small thing, sir. You may not copy, means if you want you can copy, but this is not related to this question ka answer. This is one conceptual backing. Okay. Now, sir, market return in each year, then security return based on our equation, characteristic market line equation. What was the characteristic market line equation, ma? 1.202 RM minus 0.58. Next one, I will write actual return of security. Sir, this fact, this formula ka answer. They both ideally should match, but they will not match. Why will they not match? Because our line, straight line, is not a real straight line, like a dummy straight line. Pakka gap will come. A gap only we are calling it as what? Error. Now, take market returns all 6 years. Tell me one by one. 8, 12, okay. 8, 12, 11, minus 4, 9.5, minus 2. Now, what you will do is, RM substitute in the formula and get me security return according to characteristic market line equation. So it will be 1.202 into 8 minus 0.58, 9.036. 1.202 into 12 minus 0.58, 13.844. 1.202 into 11 minus 0.58, 12.642. Into 4 minus the minus 0.58. How much is that? Minus 5.388. 1.202 into 9.5 minus 0.58, 10.839, 1.202 into 2 minus, of course, minus 0.58, minus 2.984. Sir, this is the returns that should be there according to equation. Indirectly, sir, e second column, whatever you are seeing, whatever we just now computed, adi line ka points. On the line, e point will come. But reality, return is something else. What is the actual return? First year return, sir. 12 to start. Okay. 12, 15, 11. Tell me, sir. 12, 15, 11, 2, 10 and minus 12. 2, 10 and minus 12 or 12 minus 12. Now, check the gaps. Keep constant with the gaps, sir. I mean to say, either do second column minus third column or third column minus second column. Your wish, but consistently maintain. Otherwise, what will happen? A plus or minus a problem will come. Okay, 9.036 minus 12. Or else you do actual minus this, because that is more numbers are like that. So 12 minus 9.12 minus 9.036, 2.964. My actual return is higher than my line equation ka return. This is positive error. 15 minus 13.844, 1.156. This is positive error. 11 minus 12.642, negative error, 1.642. 2 minus of minus means plus 5.388, 7.388, positive error. Negative 0.839. Minus 12 minus of minus plus 2.984, minus 9.016. According to equation, I should deliver this much return, but actual return of the security is even worst. Extra deviations, whatever you are seeing, last column, either positive or negative, that is because of company's own risk factors. That's why this is called as what? Unsystematic risk. If you total this column, approximately it should become 0. Ideally, it should become perfectly 0. Since there are rounding offs here and there, it will not perfectly match, but it will match. Minus 0.839 plus 7.388 minus 1.642, 1.156 plus 2.964. This is 0.01. This is almost equal to 0. This is a proof that sum of errors will be equal to 0. With this confidence only, when we dragged this formula for expected returns, I confidently made this 0 here. This is past returns ka simple average. This is past returns ka simple average. This is past errors ka simple average. The moment I try to take simple average, what will happen? All the errors ka sum total will become 0. This is logic for writing this 0. Are we clear here, sir? This is just for your understanding, I am telling, sir. Exam now, nobody will ask you, you need not write that also. But now that anyway we did so much, one more bit also you see. Now, tell me, sir, only errors ka data. 2.964, 1.156, minus 1.642, 7.388, minus 0.839, minus 9.016. This is error ka data. Now, can you tell me expected error value? You can easily guess. Error bar 0. Why will it be 0? Because the total is 0. Average of that also will be 0. Now, deviation. The deviation of error I want. It will be the same number only, no? Again, same to same number as it is in numbers will come, because error is basically 0. Deviation of error, we got the same numbers. Now what you do? Deviation square you do. So 2.964 into equal to 8. 8.7853. 1.156 into equal to 1.3363. 1.642 into equal to 2.6962. 7.388 into equal to 54.5825. 0.839 into equal to 0.7039. 9.016 into equal to 81.2883. Correct. If you total this, somebody do it, sir. You should be getting 149.3925. Check once. Now, can you tell me, sir, deviation of errors key, if I do standard deviation formula now, it will be standard deviation of error square. This is nothing but 149.3925 divided by 6. Root I am not putting because I want percentage square terms. If you want standard deviation, put root. Divided by 6. How much are you having? 24.898. That's equal to, what is this? Sigma error means what? Unsystematic risk. Go and check. Earlier also we did 24.88. Here we are getting actually 24.89 we got. Let's round off. Same answer you will get. The formula is without formula. Error ka concept if you understand. Error ka deviations if you take. Error is what? Unsystematic risk. So many unsystematic risks are. I want average. Standard deviation formula you apply. Directly unsystematic risk will come. This formula, without residual figure, original unsystematic risk. This balancing figure, sir, the total risk systematic you removed. This is not like that. You gave me 5-6 years data, I worked out unsystematic risk originally. How did I work out? I tried to link security and market. A stupid security is not listening, it is deviating. All the deviations I captured. Our deviations, average deviation is unsystematic risk. Because the extra deviation is because of company ka own specific factors. All this is just for concept. Because anyway we are learning a route. Exam point of view not required. Exam point of view your answer gets over here. Are you getting it, sir? See, all this if you learn, concept ka backing will be very, very strong. Today you are learning all this for the first time, it will be slightly heavy. But as you go further, things will become smooth for you. Okay. Now, the 86th one is over. Come to, sir, the 85th one. This question, you can see the numbers, sir. Literally same to same. Whatever 86th question we solved, that is CA final question. This fellow copied that question and added some extra bits also. The only thing is, whatever extra questions they have asked, they are conceptually incorrect. 100% question wrong, sir. First bit work correct. Characteristic line. You can check the answer also. Same thing, no, sir. 1.202 x minus 0.58. Y is security return, x is market return. Same formula, same answer. But the second and third are conceptually wrong. That fellow who copied this question could have copied as it is. He applied his own mind in between. In fact, you tell me, sir, in column whatever you are seeing, what are they? Returns from security, return from market. Antega, sir, see the heading what he wrote. The returns on stock and market for a period of 6 years. Up to there, okay. After that, in excess of risk-free rate are given as follows. Sir, it is security return. Security return minus RF security return. But how is he describing this? Excess return is describing. It is not excess return. Excess return, how can you link? So concept is wrong, sir. Total. That's why question I did not do, even though data is same. These 2018 questions are old syllabus. Mistakes happen. Ignore this question. Or don't read ignore, because if it again comes up, you will come and catch my collar. Right? Concept. Conceptually wrong. Sir, if you have to link to securities, why to eliminate RF from that? That is wrong, no? So anyway, question number 86 when you come. This one, 10 years ka data, security X ka return, market ka return given. See this fellow's trap point. Security name is what? X, but that is standing on y-axis. When you apply your beta formula, this is not x, this is y. Ead x outside, sir. All these are stupid, cheap examination techniques. They will play like that only. అక్కడ x చూసి అది x అనుకున్నారు, అయిపోయింది సమ్. ఫస్ట్ బాలే గాన్. No matter how beautifully you write, how perfectly you calculated, 4 decimal answer you give also, 0. All these are traps, sir. Nobody is testing your concept now. It's a test of concentration. Okay, 10 years ka data. What does he want? Mother wants beta of security. That will work out. He's simply asking characteristic market line. Now what you will do is, now do a 4 column version. Finish off this. Beta alpha line. Khatam, over. Do. Regression analysis lo work out beta, please. That's easier one. Nobody asked you standard deviation, systematic, unsystematic and all. Once they asked, we show what we know. This time simply handle it. 84th question. People who are doing very fast, tell me calculation of beta. So x column is market return, y column is security return, then I want x square, I want x into y, or else first x into y, later on x square. Okay, fine. Sir, you can do a 9 column table also. Question did not specify. So you practice this one because 9 column table answer is anyway printed there. If you practice this one, you will have both the alternatives with you. Okay, tell me RM one by one. 20, first 22. Next 20, 18, 16, 20, 8, minus 6, 5, over up. Now over up. Okay. Security return 20, 22, 25, 21, 18, minus 5. Okay. First column ka total, second column ka total. First one is 120. This is 150. So which means x bar is equal to 120 divided by 10, past 10 years ka average. So that's 12%. Y bar is equal to 150 by 10, that's 15%. X bar, Y bar ready. Next, XY summation. How much? 440. Again 440. 450. 336. 360. Minus 40. 102. 90. 42. 220. Total. Next, x square 484, 400, 324, 256, 400, 64, 36, 25, 121. Sir, up to here, the only mistake you can commit is in notations. If you write wrong, gone some. Be careful. But this particular model has got the advantage that instead of doing 9 columns, 4 columns, half time la answer will come. But you should be careful. Beta formula. Summation of not sigma, summation xy minus n into x bar y bar divided by summation of x square minus n of x bar whole square. Summation of xy is 21. Okay, fine. 2157 minus 10 into 12 into 15 divided by 2146 minus 10 into 12 whole square. 0. Okay. So guys, this is your beta. 9 column table also you can do, sir. You will get to the same answer after 5 more minutes. That's all. That's the only difference. Beta is ready. Now he is asking characteristic market line. Characteristic market line. Your thought process should be like step 1, step 2, step 3. Step number 1, beta security is equal to 0.5057. Step number 2, computing alpha. How to compute alpha? First equation you write, which is y is equal to mx plus c. Return of security is equal to beta security into rm plus alpha. If you directly want to do, directly write this for expected data itself. Directly answer will come. Expected return of security is who? 15, correct. Beta is 0.5057. Rm expected 12 plus alpha. So which means alpha is equal to 8.93. Chiller, leave it. Okay, fine. Step 2. Step 3. Equation. Very small concept, but exam point of view high important. So security return is equal to beta security into Rm plus alpha. So security return is equal to beta 0.5057 Rm plus 8.93. That's it, over sum. Will hardly take 6 to 7 minutes, sir. 8 marks. Beyond that, if you invest, you lose time for other questions. That is that. Any doubt in this? With that, we are done with our concept called as characteristic market line equation solved. Now